Hello guys, welcome back to my channel. In this video, I'm gonna review some concepts of engineering related to being a mechanic or MM. Main concept in engineering that we learn in A school is, or in just engineering in general. I'm guessing if you're dealing with naval um, engineering, would be basic steam cycle. So there's four phases of steam cycle. So over here, I just made an icon. I know it's not the best drawing for a boiler or anything that generates steam or power, right? So this is the boiler over here. So this one is in the generation phase. Again, whatever creates the steam or power for the ship could be a nuclear, powered ship or steam powered ship. Again, so that's gonna be the generation phase. So it creates the steam for it, and it goes to over here, the expansion phase, expansion phase, which goes to the engines. So the engines or machines are the one using up the steam power. Again, I don't want to go in detail in this video. No, I'll probably create another video about that one. But so the steam that's created during the generation phase feeds the engines. It could be high pressure, low pressure turbines, and it expands this steam so that it can be usable by the machines, whether it's main propulsion steam or auxiliary steam. Then once all the steam is used up, the machines are already exhausted the steam, then it goes to over here on a third phase, which is condensation. So this one, the steam is absorbed, right? And then after that, it condenses to back to liquid form and during the condensation stage. Um, and then after that, it goes to over here to feed, which is the deaerating feed tank. So DFT is the one, once the steam condenses back to water, and the DFT, the job of the DFT is basically purging out the air out of the system. It goes to the atmosphere so that it's not gonna create aeration or any problems within the cycle. And then again, the cycle just goes in circle. So they created this concept before because they noticed that if it's not like this, the steam is just being wasted or fuel. So that's why they created a system that is more efficient, that can allow the ship to actually provide steam for a longer period of time. Because again, if you're asking or thinking about yeah, there's gonna be a steam wasted on this cycle. Yeah, there is, but again, there's also there's a part of the system that actually augments whatever is lost over here during this the process. But that's the basic ones. Again, I'm not gonna go into detail because some of them are not supposed to be shared. And all right, over here, we're gonna talk about the common laws that applies to engineering over here. So we have the Boyle's law. So over here, I just made a shortened version of the description of the law. So over here, the Boyle's law is just when the temperature over here, given the temperature is constant, the pressure of the fluid is inversely proportional to its volume. So as the pressure goes up, the volume goes down, and vice versa. So the volume goes up and the pressure goes down. So that's the Boyle's law. Charles' law over here, the concept over here is just the pressure is constant over here. Pressure stays same, but the temperature, if there's an increase in temperature, there's also an increase in volume. So they're directly proportional. So that's why when something is overheating, the volume of the thing that's inside, whether it's going to be a water or pressure, it's going to just go up, and that's what going to be blowing up or explode, right? That's the cause of explosions. Pascal law over here, the common examples that they teach people in engineering would be because this one is pressure 1 and pressure is equal to pressure 2. So basically, if you increase the pressure of fluid, right? So the the pressure is going to be equally distributed on all sides. So that's why like it's equal. And the ideal gas law over here, so it's just like a combination of all the laws and that we already covered over here. So times volume is equal to nRT. So n is the number of kelvins over here. So N would be the number of moles and R would be the ideal gas law constant. And T it's like equal to 8 point something. Remember, and then T is for temperature. So that. So if you multiply those three, is equivalent to the product of pressure times volume. And also the common ones that they're gonna ask you to learn also, like not just in engineering, would be the temperature conversion. Because again, Fahrenheit is higher than Celsius, right? So whenever you're converting Fahrenheit to Celsius, or example over here, so in order to get the Fahrenheit, we're looking for Fahrenheit. So you're gonna have to do like degree Celsius times 9/5 plus 32. So example, like we're looking for, we're going to convert 40 degrees Celsius to Fahrenheit. Celsius. So it's equal to 40 times 9/5 plus 32. All right, we're gonna do this one first. So 40 times 9/5 and then 32. So I don't have a calculator, so I'm gonna do it in my own. So 40 times 9, so 36. So 360 over 5, so 635. Alright, so it's equal to 62 plus 32. So that would be equal to 94 degrees Fahrenheit. So I'm sorry, so it's supposed to be Celsius over here. So alright, and then if you convert the Fahrenheit to Celsius, it's gonna be this formula. So degrees Fahrenheit times 5/9 minus 32. So just follow this one, and that should be able to help you get the correct answer. Alright, thank you guys for watching this video. Hopefully you learned a bit or something. Alright, but again, take care. Have a nice day.